Okay, we're making a statement, reason, proof. So we want to start with a single statement, and there are two of them. B or not F. Either one is okay. It couldn't be a G or a J because they're embedded in a compound hypothesis. But either of the two single statements in this problem would be okay. So I'm going to start with B. So I'm going to take B, and I'm going to take B implies not D. So B implies not D and B. Now I'm going to put them in a different order up here because I usually put the single statement by itself. So I'm going to put in B first, which is given. And then I have B implies not D, which is given. Every statement and reason are numbered accordingly. Now I'm going to put these two together. Because it's a conditional of which the hypothesis is given to be true, then, think of a dotted line here, the conclusion must be true. Because T implies T is true. T implies F would have been a false conditional. So by modus ponens, our conclusion is not D. And then we put the line numbers, and this is required to show what line numbers we used to arrive at this conclusion. Okay? Now, we have D. So I want to go to something that has D in it. So I have C or D, and then not D that I just put into the proof in number 3. Now I'm putting it over here on the board because I like to see the disjunction or conditional and then the single statement below it. I think it's a little bit easier for you to see. This is a disjunction, an or. It cannot be modus ponens or modus tollens. They are for conditionals. This is a disjunction. Walk through the solution. Not D is true. Everything in our proof are true statements. So since not D is true, D is false. Well, this is a true disjunction. That means that one of the two has to be true. If it is not D that's true, then it must be C that's true. So I'm going to bring in C or D. Which is given to be true. And then based on that and the reasoning that I just put here on the board, C is true. And the reason, and I do let you abbreviate this one, is disjunctive inference based on lines 3 and 4. Okay, now I want to go to our list again, bring in something that has C in it. So I'm bringing in G implies not C together with C that we just put in the proof. Now this is a conditional. So it's either modus ponens or modus tollens. It is the negation of the conclusion. So because the contrapositive is logically equivalent to the conditional, then we have not G by modus tollens. The negation of the conclusion means the negation of the hypothesis, and that's modus tollens. So I'm going to bring in G implies not C. And then based on what I just put on the board here, not G is true. And that's by modus tollens. And the line numbers are 5 and 6. Now I go back to the list, and I want something that has G in it. Well, I have G in it, but it's embedded in the compound hypothesis. So I'm going to leave 7 and just let it hang there. I'm going to come back to it. 7's just going to hang there for a minute, because now I'm going to take these two and put them together. Because I can't get into that compound hypothesis. So I'm going to take not G and not J implies F together with not F and come up with a conclusion. I'll leave this one alone for a minute. I'll come back to it and use it later. So the negation of the conclusion means the negation of the hypothesis. Don't actually negate this or simplify it. That's a different step. But the negation of the conclusion means the negation of the hypothesis by modus tollens. So I have the negation of not G and not J. And that's by modus tollens. Lines 8 and 9. I'm just putting it above it because I need more room down below. Now I'm going to simplify the negation of that parenthesis. Not G is G. To negate a conjunction, it becomes a disjunction. And not J is J. And that's by De Morgan's. On line 10. Now, I'm going to take 7, and I'm going to take 11 and put those two together, 7 and 11. So 11 is G or J. 7 is not G. This is a disjunction. It cannot be modus tollens or modus ponens. So let's walk through the solution. Not G is true. That makes G false. One of them had to be true, so it must be J, which is exactly what you were supposed to be proving, and it's by disjunctive inference. And that uses lines 7 and 11.